if photons have energy and energy equals mass, does that not mean that photons have mass?
Uh, okay, so two fast points here. Photons are pure energy.
Pure energy.
There is a mass equivalent of that energy,
Right.
but while the photon is energy, it does not have mass.
Right.
Okay? It is pure energy.
What happens when scientists try smashing something together that, by all logic, shouldn't even exist? That's not just a wild thought experiment anymore. It's the kind of high-stakes gamble being played out right now at the razor's edge of particle physics. Fermilab, one of the world's most famous particle accelerator labs, has taken their experiments to a level that's raising both excitement and serious alarm. Their latest obsession? Colliding a dark photon, a mysterious invisible particle that might be tied to the riddle of dark matter itself. This isn't just science stepping forward, it's science leaping off a cliff with no parachute. We're talking about a move so bold that many researchers are warning it could rewrite, or even rip apart, the very rules of the universe we thought were unshakable. Imagine creating a ripple that doesn't just shake equations on paper, but bends reality itself. A wave of physicists and ethicists are now sounding alarms, some even saying that this isn't just dangerous, it's reckless. The fear is chilling. Tampering with dark photons could destabilize the fragile balance that holds the cosmos together. This is no longer about curiosity or pushing boundaries for the sake of knowledge. This is an ethical minefield, a moral showdown about whether humans should even touch the building blocks of existence at all. Picture it, standing right at the cliff edge of discovery, staring into the unknown, knowing one wrong move could crack open reality itself. This experiment carries a chilling potential. It could be the master key. A key that opens a door we may never be able to shut again. And this isn't some sci-fi exaggeration. It's the razor's edge. Fermilab is walking right now, where the hunger for ultimate knowledge slams head-on with the most dangerous unknowns in the cosmos. The promise is massive. Answers to the deepest mysteries of the universe. But the risks? Unimaginable. We're talking ripple effects that could shake the very stability of reality itself. Fermilab's new dark SRF experiment has already made history, achieving the highest sensitivity ever recorded in the hunt for dark photon conversions. This breakthrough doesn't just push boundaries, it tears through them, bringing us one step closer to confirming whether the dark sector, the hidden scaffolding of the universe, actually touches our own. That possibility alone has physicists buzzing with equal parts awe and dread. At the center of this daring experiment is a deceptively simple yet incredibly powerful idea. Scientists are hurling ordinary photons into ultra-cold superconducting cavities, engineered with mind-bending precision. These frozen, high-tech chambers are designed to squeeze reality until it cracks, forcing the universe to whisper its most guarded secrets. If even the faintest trace of dark photons emerges, it means the hidden fabric of existence just brushed against ours, and that revelation would change everything. To really picture what's at stake, imagine the night sky stretched above you, bursting with stars. Now, envision every one of those stars being held in place by an invisible skeleton, a vast cosmic scaffolding we call dark matter and dark energy. It makes up most of the universe, yet we can't see it, can't touch it. Fermilab's bold experiment? It's like giving that invisible scaffolding a dangerous shake just to see if it moves. The entire goal here is simple, yet terrifying. Shake the universe and see if it rattles. If even the faintest tremor is detected, it would mean our visible world is secretly linked to the dark sector lurking in the shadows. But this isn't just about finding a connection. The darker fear among researchers is that if these hidden particles really do touch our reality, they could unleash forces far more powerful than we ever imagined. Forces capable of rewriting the way galaxies themselves are held together. That's why this experiment is no routine test. It's a direct probe into the very fabric of existence. Fermilab's team isn't just poking around with photons, they're challenging the foundation of cosmic architecture itself. The outcome could blow apart our current understanding of how the universe formed, how it evolved, and maybe even why it still stands. A tiny rattle in the data could be the first whisper of an entirely new physics, a physics so revolutionary it could flip our perception of the universe on its head. And here's the real kicker. What if this isn't just a scientific mission, but a point of no return? If dark photons really interact with our world, theory suggests we'd see faint resonances, ghostly echoes hidden inside our most sensitive detectors. These tiny anomalies could be the fingerprints of forces or dimensions we've never seen before, shaping our universe quietly from the shadows. Imagine that. Parallel realities brushing up against ours, influencing everything we know while remaining invisible to human eyes. If Fermilab's gamble pays off, we might not just uncover new physics. We could be opening a door to hidden worlds we're not ready to face. This is more than just a scientific puzzle. It's a crossroads for humanity itself. Do we keep pushing deeper into the unknown, chasing this ghostly particle until we finally drag it into the light? Or do we stop, step back, and admit that some doors should never be opened? Because once they swing wide, there's no slamming them shut again. The hunt for ultimate knowledge has always carried danger, but the dark photon might be the most dangerous chase of all. And here's where it gets personal. You. What do you think this discovery would really mean for us? Could it flip our understanding of the universe upside down? Could it redraw our place in the cosmic order? Drop your wildest theories in the comments, because your take might be closer to the truth than anyone dares to admit. But let's not forget, this isn't science fiction. This isn't fantasy. Fermilab has already run tests built to sniff out these hidden forces. And the results? What they didn't find could be just as haunting as what they hoped to see. Sometimes silence in the data screams louder than any signal, hinting at mysteries we're not yet ready to grasp. So the real question is, are we prepared to peel back the veil of reality and stare into the chaos behind it? Are we ready to accept that the universe may be layered, twisted, and far stranger than anything we've imagined? Because if these hidden forces are real, they won't just tweak our equations, they'll rewrite everything we thought we knew about existence itself. The quest to peek behind reality's curtain is only just heating up, and with it comes the old playing God debate. Remember the panic when the Large Hadron Collider was accused of spawning black holes? CERN swore it was safe, yet fear never fully faded. Now Fermilab is taking things even further, pushing against an invisible boundary that might be more dangerous than anything we've seen before. This isn't about smashing protons anymore, it's about slamming into the very walls of reality itself. Think about it. If the universe is held together by a hidden code, are we trying to hack it? And if we do, are we ready for the glitches that come spilling out? Because poking at forces tied to dark matter isn't just risky, it could unleash ripples across the cosmos that no one can predict. This isn't just science anymore, it's a moral war over whether humanity even has the right to rip away the universe's most guarded secrets. Dark photons, if they're real, aren't just another theoretical particle. They could be mediators of a dark force, and the consequences of finding them could be nothing short of cosmic. Imagine these elusive particles colliding not only with matter, but with each other. The result? Explosive particle showers that our detectors aren't even designed to handle. Strange signals, bizarre cascades of never-before-seen particles, all screaming hints that physics as we know it has just been shattered. The scariest part? These events would force scientists to admit that the standard model, the bedrock of modern physics, is incomplete. It wouldn't just rewrite textbooks, it would rip them up and toss them in the fire. And once that door is opened, there's no telling what else could come pouring through. The biggest bombshell lurking in dark photon research? The possible discovery of a fifth fundamental force, something that would rip physics wide open. Right now, our universe is ruled by four forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. But if dark photons exist, they could be the messengers of an entirely new force, one that doesn't just tweak reality, but reshapes it at scales we can barely imagine. This mysterious fifth force could influence how dark matter behaves, how dark energy drives cosmic expansion, and maybe even how the grand architecture of the universe itself is built. The fallout from such a discovery would be earth-shattering. It wouldn't just shake cosmology, it could obliterate the lambda CDM model that currently underpins all of modern astrophysics. That model relies on dark matter and dark energy as the scaffolding of the cosmos. But if dark photons bend those rules, then the very blueprint of the universe collapses into uncertainty. Picture it like hammering the base of a massive skyscraper. On the outside, the building looks strong, unshakable. But one strike too many, and suddenly hidden cracks start to show. Weaknesses no one ever noticed. That's exactly what these dark photon experiments could be doing. Stress testing the foundations of existence itself. Maybe the structure holds. Maybe our physics stands tall. Or maybe, just maybe, the hammer blow reveals something shocking. Entirely new principles governing reality that we've never even dreamed of. And once we see those cracks, we'll never be able to look at the universe the same way again. Here's where it stops being abstract science and hits home. It gets personal. If a new force carried by dark photons is proven real, the impact won't stay locked inside lecture halls or dusty textbooks. It could transform the very tools we live with. Imagine energy systems that pull power from this hidden force, or futuristic communication tech that rides its mysterious waves. This isn't just theory. It could rewrite how we power cities, how we connect across the globe, maybe even how we travel through space itself. But the influence wouldn't stop with gadgets or technology. This discovery could twist our entire view of the universe, how it was born, how it grew, and even how it might one day die. We're talking about a revelation so massive it would stretch from the tiniest particles to the vastness of the cosmos, reshaping our sense of reality at every level. Picture a force so fundamental, so deeply woven into existence, that finding it would make everything we thought we knew about physics feel like child's play. One bold experiment, one shot at the unknown, could hold the key to unlocking truths we've been chasing for centuries. This isn't just doing science, it's humanity clawing at the very edge of the possible, daring to test whether the universe has been hiding secrets right under our noses. Whether these dark photons exist or not, every result pushes us closer to answers that redefine who we are, where we come from, and what reality itself is made of. Let's be clear, Fermilab's hunt for dark photons isn't wild guessing. Their methods are razor-sharp, dark SRF, sequest, and light shining through walls experiments. And the result so far? Nothing. No dark photons. But in science, nothing still speaks volumes. Every failed attempt slams a door shut, showing us where the secrets aren't, while keeping us searching for the one door that finally swings open. And here's where the "don't play God" warning comes roaring back. Because every step forward feels like creeping closer to a doorway we may never be able to close again. We're not just poking at the edges of physics. We're mapping the edge of human knowledge itself, one careful shot at a time. The universe won't give up its secrets easily. But you better believe we'll keep pressing, keep asking, keep pushing. Dark photons dangle in front of us like a forbidden prize, an extension of the standard model, a possible gateway to hidden forces shaping reality. And Fermilab isn't alone. CERN, Babar, Jefferson Lab, they're all chasing the same phantom, all sailing straight into uncharted territory. Just like the explorers of old, we're venturing beyond the maps marked "Here be dragons." And sure, sometimes explorers found new lands. But sometimes, the dragons were very real. History has shown us this pattern again and again: nuclear research, quantum mechanics, the Large Hadron Collider. Each time, the public feared we'd gone too far. And each time, we cracked reality open just a little wider. We're not just running experiments, we're literally writing humanity's next chapter, carving our story into the fabric of the cosmos. But here's the burning question. Even if we can open the door to hidden forces, should we? That's where you come in. Drop your take in the comments, smash that like button, and subscribe so you don't miss what comes next. Because the dragons may be real, but so is our courage to hunt them. The models of the universe may be pointing us in the right direction, but something vital is still missing. Black holes hold an enormous influence over the cosmos, yet they guard their secrets like vaults, refusing to give up the full truth. Even with the unmatched power of the James Webb Space Telescope, humanity hasn't cracked the code of these cosmic beasts, not yet. And maybe that's for the best. With our telescopes, we're already staring into billions upon billions of stars, each carrying data so overwhelming that it's almost too much for us to process. Sometimes the universe reveals itself in fragments, forcing us to piece the puzzle together slowly, step by step. If you're ready to keep chasing these cosmic mysteries, don't forget to subscribe, like, share, and drop a comment. Because the search for answers is only just beginning.